All right, so now we've got our own custom evaluation functions. We can evaluate how our model is doing. So the next logical step would be to train another one on the training data set and then evaluate it on the validation data set, or just using this beautiful function that we've crafted. Not so fast. Let's see why. So testing our model, this section is going to be, we're going to do it on a subset. So testing our model on a subset. Now this is mostly to tune the hyperparameters. Because remember what we've been stressing, we want to decrease the amount of time it takes us between experiments. And if we come back up, remember how we time traveled in a previous video? And that took 6 minutes 58 seconds to fit a model on all those data, so on 400,000 rows. We don't have enough time to do that again. We can only time travel every so often. And so if we were to just write it out again, if we would instantiate our model, so model equals random forest regressor, n jobs equals -1 and a random state of 42. Wonderful. And then if we just did model.fit xtrain, I need to be careful here not to be trigger happy. If we did this, right, if we put a little time up here, time, that's going to take far too long, right? So we might put a note here. This takes far too long for experimenting, because that's going to take about 5 minutes. That's not what we're after. And again, if you have run this cell before, actually I probably should have told you this earlier. If you did run this cell on your computer and it's taking far too long for it to load, remember, you can always press the stop button up here. So if we run this, oh, well, that's too fast. That runs too fast. But if your cell is running, remember how there's a little star here? I'll show you. There'll be a star. Well, that happens too quick for this. You're going to have to trust me on this one. When you run a cell, this will turn into a star if it's running. You can stop it by pressing this button with that cell highlighted, and that'll stop that cell. So we'll come back. Let's not run that. We'll make sure we can't. So we comment it out. Beautiful. Because why? Because our data frame is 400,000 rows. There. And my little MacBook Pro has already calculated a lot of patterns in 400,000 rows, and it's like, well, I'm going to take a while, so you need to be patient with me. Well, that's fair enough, because I would take far longer than my MacBook Pro does to calculate through 400,000 rows. So, what our solution is to speed up our time between experiments, and that's what we're doing, testing our model on a subset. We could do something like this. Could just copy this, model.fit. Maybe we want to only do it on 10,000 rows. But there's an even better way, and it's right built into, we could do that. Right, that's going to test it on 10,000 rows. But nah, there's a better way to do it. That is one option, so keep that in mind, that you can just slice your training data set. But the beautiful thing about random forests, and this is why we're focusing on it so much, is that they have this little feature in it called max samples. So change max samples value. All right, and if we wanted to figure out what max samples does, where would you go? Well, one option is if we go model equals random forest regressor. We're going to have heaps of practice instantiating these models. This is what it's about though, right? It's just about almost making this second nature on what it's like to just get a model instantiated, get it ready. Random state equals 42. There's our model. So that could be one option. But if we press Shift Tab here, we'll see the doc string, max features, max samples. Max samples. Boom. Now if we come down here, let's find it. Max samples. There we go. If Bootstrap is true, the number of samples to draw from X to train each base estimator. What does this mean? So if we go model, okay, Bootstrap equals true, yes. And now each estimator sees max samples. Now where's max samples? None. So what does it mean? If none, it's going to be all, isn't it? Let's have a look. This is one I want you to have some practice doing, right? Is if you're not sure on something, it's looking it up and reading it in the docs. If Bootstrap is true, the number of samples to draw from X, okay, so X is what we pass the model. If none, then draw X.shape samples. So it's going to draw them all. Now, if int, then draw max samples. So, what this means is that if we go xtrain.shape 0. So if we leave max samples as none, every estimator, and in our case there's 100 because the default n estimators in random forest regressor is 100. So you can imagine n estimator as a small model. So each small model, so 100 small models are going to see every single one of these. So that's a large number, right? So this is all the calculations that we have to make, probably more than this, but this is what you can imagine. But instead, if we set max samples to something else, so say for example, maybe we only wanted to try 10,000 examples instead of 400,000, right? So closer to the shape of our validation set. We could change max samples set to 10,000. So this means that instead of looking at 400,000 rows, every estimator, so the 100 estimators for n estimators, we could also change this to be honest, but we'll leave it as default just for this example. So that means because we changed it to 10,000 times 100. Wow. So let's have a look here. Let's divide these two. How many times less? What do we got here? What number is that? How many zeros is there? 1,000,000. That's 1,000,000. I can count. 40 times less. So 40 times less data to compute on. So that means we should see a speed increase of 40x, or about that, right? Because it's not going to be perfect. So let's go here, change what we might do. Yep, that looks good. And then we'll create a new cell here. We'll leave our little time here because this is what we want to practice. So cutting down on the max number of samples each estimator can see improves, well, this is our hypothesis, improves training time. And let's have a look, model.fit. We'll do it on our training data now. So this shouldn't take too long. Maybe we might even have time to wait for it. Still might take a few seconds. This might be another opportunity to time travel. Oh, we didn't need to time travel much. Look at that. Wall time, 16 seconds instead of 7 minutes. Now that's a bit better, right? Now that's something that we can potentially just sit here and wait for. If you're doing 7-minute experiments all the time, or even longer if you had more data, you're going to lose patience, you're going to get distracted. But if we can keep our experiments like somewhere around 10 seconds, so that's pretty good, right? I can wait 10 seconds. And now the beauty comes in here when we can call our show scores function. So let's see what happens when we go show scores. Hopefully this works because we've coded up this function ourselves. Of course it will. Show scores. What are we going to find? Oh no, we've messed it up. NumPy has no spirit instead of square root. This is where we've messed up. NumPy, there we go. Typo, classic. Couldn't get it right the first go, could you, Daniel? Nope. So we'll see how our model does. We've just trained it here on a subset of the data. Beautiful. All right, look at that. So training mean absolute error. So valid, yeah, see here how I said the valid error will be slightly higher than the training. That's good. That means we're not overfitting. And our R squared for training and valid are far worse than the 0.987 we saw before, but that's all right because we're only training on a subset of 10,000 examples, not all 400,000. So we'd expect these metrics to be worse than if we were to set max samples to be none or train on all of the training data. Now, what we might do is see, this is our valid RMSLE of 0.29. I wonder where, if we were to compare that figure with the leaderboard, where would we end up? So there's about 425 teams in this competition. So if we were to submit our sample as it is now with our valid RMSLE score of 0.293, only on 10,000 samples, where do we end up? 0.293. Wow. We're in the top 100. Look at that. we're in the top 100 with just a simple model on 10,000 examples. So somewhere in here. All right. Now we've got an idea of how to train our model a bit faster. What we might do is try some different hyperparameters. And I'll let you think about it before we get into the next video. What's a way to find different hyperparameters rather than us having to manually adjust these hyperparameters of our random forest regressor? If you're not sure, don't worry, we'll cover it in the next video, but have a think. How have we found better hyperparameters in the past? Because that's what we're going to use for the next video.